cursed. Y'all are like talking out your butt. You don't even know what you're talking about. You haven't.
TikTok is cursed.
TikTok is probably cursed. That one is probably true.
That one's accurate.
That one is accurate.
But there's worse.
There is worse, is that what you said?
Yes.
That's probably true too.
I feel like on TikTok the videos are more cursed and the comments are mostly tamed, and on Instagram the videos are mostly tamed, but the comments
the
are
videos
cursed.
are
Okay, well,
half of them.
Okay, not all.
I have
It's
discovered,
always tamed, but
so,
I would say
you
generally
know,
accurate.
on Instagram, I had the bright idea at one point to be like, okay, I'm gonna, you know, they keep putting all this nonsense on here that I don't want to see on Instagram. So I'm gonna go and click and block them. So if you do that, it makes it worse because Instagram's like, oh, they clicked on the thing and then whatever. So don't do that. Don't try to, you know, if you want to like go block a bunch of people, that doesn't work. It's gonna just feed you more of the same crap. But I did discover that if instead you click on it and you hit not interested, that for at least a little while you do that. I mean, you got to do it enough, right? You got to do it to all the things on the feed. That at least for a time kills the nonsense for a time. Eventually you have to go back and do that again, but that does work. But clicking block on them doesn't work because Instagram's like, oh, you want to see more people shaking their booty? Here you go. So don't go try to block them. That doesn't work. I mean, if they're like, if some random person is messaging you, yeah, block them, do it. But you know, that's different. But if you just don't want stuff on your feed, you have to click not interested, not block. Block doesn't work. It makes it worse. Makes it a lot worse. Okay, we got some math to do. Trigonometry. No, not ick. That's false. Yeah, so why do you say ick? Because you have a bad attitude and you want to share it with the rest of the world. That's a little bit true. It's okay. You're a teenager. Most people your age, at least right now, have a bad attitude. I don't remember when I was y'all's age, the number of people having a bad attitude as the number of people y'all's age now having a bad attitude. And I'm about tired of it. We had a lot of fun together when I was a child. It was an enjoyable time of my life. But you people suck.
Wow.
Not all of you, but you know. I know, I'm overgeneralizing. But it does seem like the number of idiots is climbing. What numbers did we do? 16 through 40. Maybe I'm just old. Number 16. Who doesn't label what's what. So I'm just going to read stuff and we're going to YOLO. Oh, it's sine, cosine, tangent. Oh, sine, yeah, okay. So, I don't know if this is the right order or not, but we're going to try and see what happens. The sine of j is 30/34. The cosine of j is 16/34. The tangent of j is 30/16. The sine of L is 16/34. The cosine of L is 30/34. The tangent of L is 16/30. Number 18 is the sine of j is 4/5. The cosine of j is 3/5. The tangent of j is 4/3. The sine of L is 3/5. The cosine of L is 4/5. And the tangent of L is 3/4. 20. The sine of j is 2 times the square root of 5 over 5. The cosine of j is the square root of 5 over 5. The tangent of j is stupidly written, but it's 2. The sine of L is square root of 5 over 5. The cosine of L is 2 times the square root of 5 over 5. And the tangent of L is a half. 22. is the square root of 3. 24 is the square root of 2 over 2. 26 is 1. 28 is 30.7. 30 is 23.2. 32 is 17.7. 34 is about 24 inches. 36 is 33.7. 38 is 56.4. And 40 is 64.6. What questions do you have? Number 20.
I reduced most of these to decimals, but
Well, that's not called reducing. That's called uglifying. Reducing is if you have 8/20ths and you reduce that to 1/10.
I've spent like 25 extra minutes of my life just
Good for you. Okay. Number 20. We've got a triangle that got away from me. K, J, L. 2 times the square root of 3. 2 times the square root of 5. 15. You're right, 15. Thank you. And 4 times the square root of 3. So, we're supposed to find the sine of J, etc., and the sine of L, etc. Let's start with J. What is sine? Opposite over hypotenuse. So what is opposite J? That's adjacent to J. And not only is it adjacent to J, it's more specifically the hypotenuse.
Oh, I have it written differently on my notes. Sorry.
Oops.
In my book.
How is it written differently in your book?
Not that book, mine.
Ah, yeah, that makes sense. So, 4 times the square root of 3 over the hypotenuse, which is what?
2 square root of 15.
Okay, we don't like that. It's ugly. How should we fix it?
Multiply times the square root of 15.
Yeah. Square root of 15, top and bottom. What happens to the 4 and the 2?
Well, the 4 stays the same, but the 2 changes.
The 15, the bottom.
Wait, are you talking about 4 as in 4 square root of 3?
I'm talking about this 4 and this 2.
No, are you saying 4 as in 4 times the square root?
No, just 4.
Oh, well, it doesn't change it.
Oh yeah, it changes. Totally changes. We can totally do something to make it cleaner. We can do what you were saying you did, but you didn't do. What can we do?
I thought you would multiply first before you simplified it.
Always make things easier on yourself.
Could 3 go into
I just
squared?
If it was just this, what would we do?
divide, do something.
Change the 4 to a 2, the 2 to 1.
Right, that's going to reduce to 2 over 1. What are we going to do with square root of 3 times square root of 15?
Square root of 45. Wait. Yep.
Yeah, it's fine. What did I do?
Broke it off to its prime.
I split it up. Why did I do that? What did I see in the future that made me want to do that?
There's 2 3s.
There's 2 3s. Do you understand?
Oh, okay.
Well, good. That was an easy answer. Thought you were confused about the other. Okay. So this equals 2 times the square root of 3 squared times the square root of 5, right? Now what? Yeah. Now what? Yeah, how?
2 square root 5 over 5.
Okay. So you reduce the 3 and the 15, which is great. 3 goes into 3 once. 3 goes into 15 5 times. So yeah, you are right. It's 2 times square root of 5 over 5. That was cute. What's the cosine? What is cosine?
Adjacent over hypotenuse.
What's adjacent to J?
2 square root 3.
What are we going to do?
Simplify taking the 2 away from the 2.
Great, that's the reduced.
And then multiply times the square root of 15 over the square root of 15.
Yeah, sounds great. We already discovered that square root of 3 times square root of 15 turns into what? 3 times square root of 5. What happens over there?
Simplify taking 3 out of 15.
Square root of 5 over 5. You could have also turned this into the square root of 3 over the square root of 3 times the square root of 5 and been like, and then turn that into the square root of 5 over 5. How we doing? Do we have more questions about this problem, or did we get what we did on this problem? Did we answer the question that you actually had about this problem, or do we need to continue on this problem?
I do have a question about all the problems though. On some of the ones where you started reading off decimal forms,
I didn't do that, but continue.
like 33 point this or
Oh yeah, like on the other, yeah.
yeah. Like I had 33.69. You said 33.7.
Read the instructions.
It was to the nearest 10.
Tenths, hundredths, thousandths. There's not a once place. There's not a once place.
That's what I was meaning.
Tenths is 1 decimal place.
First one, right?
Right. Oh. So you understand that. So then what is your question?
My question is, because I did 33.69 and you said 33.7, would you count off if I did 33.69?
What do the instructions say?
Because on question 36,
Question 36 is
Did you
To the
make
nearest
this
to the
full
nearest,
homework on one
Okay,
page?
so would I count off for that? I'm turning the question back on you.
you would count off because I didn't round it to 10.
Yeah, definitely. -1. Move on with my life. Feel fine about it. Sleep soundly, more or less. Sure.
There's no way you actually fit your homework on one
Ah.
page.
I have extra one too.
Ellen, not everybody writes 3 lines worth of. 3-line
one
size
page?
things.
We did like what, like 16 through 40 on one page?
Well, see, Reese, you can't talk because you did half of it in your head. So you didn't show like any work. I already know. I don't even have to go look at the thing you turned in. I already know that's what happened.
Yeah, God. That's some crazy work to fit all of that on one page. Like, okay, at least 2 pages here, but not one page. That's
You just have to see
insane.
tiny.
I can't even read that. That is not, no.
Well, probably in your defense, Helen, it probably looks like a mess on his page, if I had to guess.
It does.
That looks like a mess as well.
But I made sure it was visible in the picture that I uploaded.
Visible at 12:18. When did you start it?
Because I did the notes, but I didn't speed it up like I usually do.
Okay, well, that's fair enough. We're supposed to find which angle? Measure of angle T. Which trig function are we dealing with? Cosine, right? Because adjacent hypotenuse is cosine. So we're looking for the angle, so we have to use what?
Where you use cosine to negative 1.
Yeah, inverse. It's not really to the -1, but it's confusing, stupid notation, so that makes sense. But inverse cosine, arc cosine, whatever you want to call it, of the adjacent over the hypotenuse. Punch that in your calculator and push enter. Make sure you're in degree mode. I probably said that in the video, but
I left the square root of 2 and that's messing up. I left the square root of 2 whenever I was doing it.
you could theoretically, I think the calculator would do it. You just have to put both of them, and you probably would have to use some parentheses or
I
something.
got like 25 something. Whenever I was doing it.
It would do it. You would just have to put it in the calculator right.
64.6 is what it says.
Well, the key agrees with you, so 64.6 degrees.
This is what I had for you. And then whenever I hit enter, I got 31
You probably have to put it, the numerator and the denominator in parentheses, if I had to guess. I'm just guessing, but
I didn't put square root of 2 in it. I just did the 3 over 7.
yeah.
What was the answer to 38?
38 was 56.4 degrees.
On problem 16 and 18, would you just get the fraction and then reduce it and not the answer?
Yeah.
Because I was dividing the bottom over the top.
You were doing what?
I would divide the bottom times over divide by the top to get a decimal.
Yeah, that's ugly. Don't do that.
That's what you did in the video.
What? I did that in a video?
Yeah.
Well, I was being ugly, I guess.
I do have a question. In the notes, you said there's going to be use special right triangles to express the tangent of 30 degrees as a fraction and as a decimal to the nearest hundred. You said something about that being without a calculator,
That's right.
but you used a calculator. How do you do it without a calculator?
Did I not give you the table? Or we did that, actually that was in a chapter ago. Yeah.
Of the Pythagorean.
Special right triangles, yeah. Like a lesson ago.
That was like 45, 45, 90, where it was
Yeah.
1 to 2 to square root of 2.
there's also, on this notes video, you said without a calculated portion.
Right. That's true. There will be a no calculator portion. It'll be ones with from special right triangles.
Well, there goes my chance of graduating.
No, I left a long time ago. I'm sorry. I thought we were in a saying stupid things contest.
Can we do 26?
I'm still kind of answering his questions.
That was cold.
Well, you said something dumb, so I had to, help it along. Okay. What are the ratios on these triangles, buddy? Buddy?
On the 30, 60, 90, it's 2, 1, square root of 2, square root of 3.
Great. Now what?
And the other one is,
Oh, wait, yeah, I got this. But it's,
I thought the square root of 3 and 1 were switched.
Definitely we're not.
the picture a little, so I get except the degrees on different
Oh,
corners.
okay, the degrees are switched.
No, I just basically drew a 45, 45, 90. Not a 30, 60, 90, so it looks stupid.
So, and then the 45, 91, I forgot where it is.
That one's easy.
It's like 1 and square root of 2 or something.
Yeah. What am I writing? Where?
So the one on the bottom, not the bottom, the base.
We could debate about which one's the base.
The hypotenuse.
You want to put a 1 at the hypotenuse?
No, I guess not.
Yeah, that would be wrong.
And then there's a square root of 2 somewhere.
Yeah, there is a square root of 2 somewhere.
The hypotenuse.
What kind of triangle is it?
Special.
What kind of triangle?
It's
It's isosceles, so what is this one going to mean? Now, therefore, where's the square root of 2 going to be? Wow. What's the sine of 30 degrees?
Sine of 30 degrees
Yeah.
would be 1 over 2.
Yeah, great. You didn't need a calculator for that, did you?
No.
Yeah.
But do I need to put it in decimal form?
Why would you need that?
Okay. Never mind. Thank you.
Can we do 26?
So, the moral of the story today is stop using ugly decimals. I don't care what past me told you. Decimals are stupid. Unless we're in physics, and we're not. What'd you say?
Can we do 26?
Sure.
I thought I was supposed to do it in a decimal, something dumb.
What's the tangent of 45 degrees? Which one? It doesn't matter. That's right.
1
It's
over
1 over
square
1,
root
so
of
it's
2.
just
It is?
1 over 1.
for either one. It's just
Opposite over adjacent.
How do you know which one's adjacent?
It's the one that's next to it.
it's not the hypotenuse.
That's not the hypotenuse.
Okay.
Adjacent over opposite.
Yeah, that's what I
No, that's cotangent. Opposite over adjacent is tangent.
So 2 over 1.
It took me like half
What are
an
you
hour
saying?
to even figure
Opposite
out.
over adjacent.
Opposite of
For the
both.
30.
Opposite over adjacent.
Oh, I thought we were doing both of them.
Either way, it's still.
Opposite over adjacent.
Well, I mean 30, 60, 90.
Tangent of 45 degrees. Why would we be doing?
So, on problem 24, would you just put 1 over the square root of 2? Would that just be your answer?
No, because it's ugly.
So then you gotta multiply times.
We've got to rationalize it. Square root of 2 times square root of 2, square root of 2 over 2.
Oh, okay.
Still ugly.
I did
As
that.
if that's better.
It is better.
It's
sure?
supposed to be, it just doesn't look better.
It's exact.
Okay.
We like exactness in math. If this were physics, that would be ugly. If I was teaching you physics today, I would yell if you put that answer on there.
Why, wait,
Because that answer would be useless in physics. But this number is beautiful because I can hand this number to a physicist and then they can get whatever precision out of this they need.
what about nobody physicist?
Well, you know, probably live happier.
Why does the square root thing on the bottom go away?
Because you can't have a square root in denominator.
You can, but we don't like it. That goes back to, all those kind of rules go back to before there were calculators, if we're being totally honest.
But we do 30.
Mm-hmm. Number 30. Wow, that's cute. I've got a lovely bunch of coconuts. It might be about 34 degrees. Looks a little less to me, but you know. And that straight curve. All right, we're supposed to solve for x. What trig function are we talking about?
Cosine.
Yeah, how do you know?
Because we have to deal with the adjacent side of the hypotenuse.
Adjacent hypotenuse, therefore cosine. Cosine 34 degrees equals x over 28. Now what?
Multiply cosine times cosine 34
Times 28. Times 28. Now this one is not a special right triangle. This one, we got some ugly looking thing. So, and you're in geometry, not like pre-cal or something. We're in pre-cal, you probably just circle that and move on with your life. But you got to shove that in your calculator and get an ugly decimal here.
That's not what I, whatever.
That's not what you, whatever. This one you didn't punch it on the calculator,
No,
the one you were supposed to.
No, I don't know.
I don't either.
I just wrote it. I did 0,
You did this first and then you multiply by 28. Is that what you're getting at?
I guess.
Probably, yeah.
Except I got 22.4 instead of 23.
Can we do 34?
Did you try it? Are you sure? If I go run over there right now, it's got work on it. Okay, all right. Okay. Number 34, gymnastics. The springboard that Eric uses in his gymnastics class has 6-inch coils and forms an angle of 14.5 degrees with the base. About how long is this springboard? And they,
This wrong 3 times before I actually did it right.
good job. Were you looking at the picture wrong?
Yes.
So the picture gives us this triangle.
Oh, okay.
And it goes 14.5 and it goes 6 inches.
That looks like a melted.
And we are expected to find how long this springboard is. So these one.
Could you say that side is also 6 inches since the other side is?
We could certainly say that, unless it was built stupid, which we gotta assume it wasn't built stupid. Or else this problem is not solvable. So, inches.
Are we supposed to find the hypotenuse? Yeah.
It says how long the springboard is, so that's definitely the hypotenuse.
Is it true that there are imaginary
Yeah, that's kind of a misnomer. It's a stupid word. They're not really imaginary, but yeah. They're definitely imaginary numbers, and they're actually quite useful for like some pretty cool high-level stuff.
I thought my mom.
Like if you go and you look at a relatively accurate weather prediction, it's because of imaginary numbers, because of chaos theory,
So like.
among other things. Also finding like the perimeter of a beach, but that's totally different. Of a beach. Chaos theory is pretty cool stuff, and that's not even the only use for imaginary numbers. But you know, whatever.
Chaos isn't a theory, it's a fact.
Chaos theory is a theory. Chaos is a word and a concept. Chaos theory is kind of almost a misnomer too, because it's not really about chaos, but it kind of is. It's about chaotic systems, which are systems that are extremely reliant on initial conditions. What should we do to solve this problem? What trig function are we talking about? Sine. Sine of 14.5 degrees equals 6 over x. Multiply times x, divide by that, we end up with 6 over the sine of 14.5 degrees. True enough. Punch it in, push enter, move on with your life.
Why isn't divided?
Times x, divide by these on both sides, and you get that.
Why do you multiply times x? Why can't
Because x is in the denominator, we got to get it to the numerator.
23, I mean 24. 20,
Like,
yeah. 24.
how would we solve this? What? Okay, so we multiply times 12. Then you get 60 equals 144 over x. Now what would you do? Multiply by x, right? Yeah, yeah, etc. Does that make sense? Good. Why don't we take quizzes anymore? What a dumb question. It's dumb for two reasons. One, I know you don't want to take a quiz, although they're useful to your life. And number two, it's relatively obvious why we haven't taken a quiz in a while.
We haven't had time.
Yeah, that's the one. Look at you, being all smart and stuff. I knew you weren't an idiot. I've been trying to tell you for a long time.
Is my calculator in degrees? How do I see?
Well, this little thing that's highlighted is a D, so yes. And you change it and do it by hitting probably setup, but possibly mode. Yeah. So you go to shift and setup, and then you do either deg or rad or grad, actually, but we will never use that. And then so you just hit 3, and then it's definitely in degree mode. And if it's got the R highlighted, it's in radians, which are definitely superior to degrees, but you don't learn about those for a few years.
Wings of
Couple
Fire
years.
is good.
Wings of Fire,
Wings
it's
of
good.
Fire, kid. I will gladly admit that. Warrior.
She loves dragons. Okay, any questions, children?
It's like an actual good series.
Let's take a quiz.
I hate you.
Well, we're taking a quiz not because of you, but because it is currently 9:45.
Well, I still hate him.
You don't actually, but you know, thanks for playing.
It's a good way to bring up your grade.
Unless you like forgot to ask questions and try to learn things, then yeah. But you know, that's a you problem. So, you know, there it is. What? No, it's a you problem. Oh, well, yeah, it's a her problem too. Except she actually asked questions, so it probably isn't. Sorry, it's got to be back to you problem. I wasn't complaining, except I was about to punch Jacob in the throat, but you know.
If I had a dime for every time I've heard that statement, I would be so rich.
You had a dime for every time you were called a lawyer in the past, and you'd be rich.
Yeah, she'd probably have like 20 dimes.
I the Fire Kid. I would gladly admit that. That is an actual good book series with furries.
Proof.
What?
Wait, no, go back right now.
Hold the horses.
You know,
People
like
pretending-
talking animals. Like that's an actual good series about talking animals. I will say that.
No, that's.
I doubt it, but you know, maybe.
Not the later books.
You know what is a
Just like the
great
first
book with talking animals, although it's quite tragic and maybe a little bit. Redwall's fine. Redwall's like
Watership
whatever.
Down.
Watership Down. That is a great book with talking animals. It's also quite tragic and a little bit terrifying, but
I'm not the same.
the film is actually really good and also a little bit terrifying.
I don't know why they have.
Not the newer like computer animated one, by the way. I've never even seen that. I have no idea whether it's good. It's probably not. I doubt it. I don't understand why Hollywood has to try to remake everything. All that I should actually stop the recording before I do all this. What?
How do you want to
As a reduced fraction.
Then it also says, and as a decimal to give you your
I don't care.
So no decimal, just fraction.
If you want to put decimal, you can, but I won't count off if you don't.
And like one of the new Waterships Down ones, they like sing this like weird love song.
I don't know.
So weird.
I've not seen the new film, so I can't really comment on it.
The song is beautiful, but it's so weird.
It's probably stupid. I don't understand why we have to